we're just going to do kind of what we did with x squared. Now we're applying it to a new parent function today. So just to get us kind of ready, so part of your quiz was to label your graph with the transformed equation that we were working with. Now, if we have a new parent function, kind of the rule of what we want to do here is we want to remove this part, because this part is the f at x that represents that parent function. And we're going to take this whole set of brackets here, and we want that to be included inside the main operation of what the parent function is doing. So this parent function right here, what is the main operation of that parent function? Derek? Yeah, that's right, to square root. So everything, the k and the d, this whole bracket right here, that needs to be underneath the root, and then the a and c kind of stay outside. So to write the final transformed equation here, we would be writing a square root over that whole thing. And then you can keep the brackets if you want, but as long as it's under the root, I think we get the idea. And then, actually maybe that's a bit too far, because we don't want the -5 to be under the root, so we would just do this. And again, if you want to keep those square brackets, knock yourself out. Okay, so that would be our new equation. So we're going to work on doing that today in our graphs. Good on that? Okay, so parent function key points. So we need to use different key points based on what our parent function actually is. So yesterday we were learning about the function f at x equals x squared. Now we are going to be working with the function root x. So we've graphed this a couple times before, but our key x's, Maria? Yeah, exactly. So our x's are kind of like strategically chosen here so that we actually chose some perfect squares, 0, 1, 4, and 9. And then all that we need to do to get the y's is our function is telling us to square root. So we will square root to get the y's. So 0, 1, 2, and 3. And then when we kind of like graph a little sketch of this, we get 1, 1, and then 4, 2, and then we get a 5, 6, 7, 8, 9, 3. So it ends up looking like a parabola on its side. Okay? We don't choose any x's for our key points, because if I choose any x's that are below 0, then I'm trying to square root negatives, and that's actually an undefined area of our graph. Okay, that's why we actually don't go any further left than this 0, 0 point here, because I can't square root negatives. So none of the negative x's are on my graph. So we can only do 0 and above. And again, I could, like a lot of people always ask me, like, where did these points come from? Why did you choose these points? I could have chosen very easily 0, 1, 2, 3, 4, 5, right, if I wanted to. But when I go to square root something like 2 and 3 and 5, I'm getting decimal values for my y's. So we just kind of strategically chose these x's, so knowing that we're going to have to square root them to get our y's. So we chose perfect squares. Okay, I could even do, like the next point here, I could do 16, 4. So we don't usually go that high, but I think these are a good set of 4 points that we can use for this graph. Okay, so we're going to try some of them now. So we need to identify our transformations. Of course, we are graphing with our parent function, root x this time. So you're just going to have to look out for what your parent function is, because eventually we're going to be doing all of these together. So we're starting with these points. These are what we want to transform. What transformations do we have here? We have an A, yep, and a C. Okay, good. So one really great thing that you can do before you do any of your work here is you could kind of do what we did on our quiz today. You could make a little prediction graph up here. So if I started with the parent function like this, my graph is being vertically compressed by a half. So it's kind of like, it's like we're taking it and we're squishing it vertically. So it would kind of do this. That would be my first transformation with an a value of 1/2. And then from there, what does the c value of +1 do? It's shifting, shifting everything up 1 unit. So if we shift up 1 unit, it would kind of look like this. So this is the final graph with the shift up 1 unit. So I should expect, again, this is just a little thing that we can do just to kind of like predict what our final points should look like. It should be pretty quick, right, if we know kind of our transformations. And it also allows us just to double check our final answer after we've done our calculations to make sure that we get something similar. So if I have a good understanding of transformations, I could do this little sketch first and just kind of make a prediction. Okay, so we're going to do some actual calculations now. So when I set up my calculations, remember we said this is 1 over kx plus d, and then ay plus c. Now here I actually don't have any k and I don't have any d, so the x's will actually remain the same. There's no change to those, so I can just recopy them. But the y's, I want to half the y's, and I want to add 1. So we're going to take a couple seconds and do that to these y coordinates, 0, 1, 2, and 3. Okay, I got 1, 1.5, 2, and 2.5. Okay, so the first thing that it asks me to do is to graph my parent function. So I'm just going to do 0, 0, 1, 1, 4, 2, and 9, 3. Okay, and I'm just going by ones on my graph, so you can just write a little scale here so you know. Okay, and then we'll write the transformed graph, so 0, 1. This is already looking good because it's looking similar to what we predicted would happen. And then 4, 2, that one didn't change, did it? 2, half of 2 plus 1, okay, yeah, that one stayed the same. And then 9, 2.5. There we go. So our prediction was like slightly off because we didn't have it like crossing over that black graph there, but because of the horizontal compression that ended up happening. And then we're just going to label it with our final transformed graph. So in place of this, I essentially just want to put in like a root x there. So my final graph here of g at x, I'll write it over here, or my final equation I should say, is half root x plus 1. Nicole, you look like you have a question. You sure? Okay. Any questions on this one? No? Okay, can I slide, or are people still copying? I'm good? Okay. All right, what 3 transformations do I have here? Maria? A, K, and D. Let's make a little prediction here. Okay, I've got my parent function. Something like that. Okay, let's do the first one. What is the A value telling me to do? Flip. Okay, so vertically, I should have something like this. That's when my A is -1. And then from that, my K value of 2, what is that saying to do? Horizontal compression by 1/2. So think about if you're taking your graph and you're squishing it together more horizontally, what's going to happen is this will kind of go like probably out like this a little bit, right? When I squish those together, it's gonna, this one's kind of hard to do, the horizontal compression. Imagine the horizontal compression, but sorry, this is not working for me. There we go. Okay, k equals 2. And again, I'm basing it off my first graph, so I always work from the new graph that I'm sketching here. And then d value, what is that telling me to do? Right 3. So I take this blue one and I shift right 3. So it's here. And now I have a final graph, something like this. So that one will be my final with the d value of 3. Okay, so that's what we're expecting our final graph to kind of look like, in that general position, and probably like it should look like it's horizontally compressed, okay? This is, again, just a really quick thing that you can do. You don't have to do it. I might ask you something like how I asked you on the quiz, like show me a step-by-step, in which case then you have to do it. But if it's just to calculate the points, you don't have to do it. It's just good to check to pre-predict your answer. Okay, so our parent function key points, because my parent function is root x, I'm starting with the same key points as what we had above. And then we're going to do some transformations here. So what should the tops of these like little table of values look like? Kaylin? Any idea?
Well, you would have to do like the kx first.
Mm-hmm.
So like it would be 1 over 2.
Good. Reciprocal of k.
And that's it.
And what about the d?
Plus 3.
Plus 3. Got it. Good. And then the a is just -1, so we have negative y there. Awesome. So remember, reciprocal of k and switch the sign of the d value. Okay, so our y's are all just being multiplied by -1. Those are quick calculations for us. We'll do those first. And then our x's, we want to half all of them and add 3 to them. So I think we'll get 3, and then half of 1 is 0.5 plus 3 will be 3.5. Half of 4 is 2 plus 3 gives us 5. And then half of 9 is 4.5 plus 3 gives us 7.5. Okay, so we're going to graph our parent function. Again, I know that this seems redundant, but the more that you do it, the more that you'll kind of commit these graphs to memory, and you'll be able to graph them more quickly next time, right? So if we keep doing it, you guys will kind of get the hang of graphing them quickly. 5, 6, 7, 8, 9. So there's my parent function. And I'm just going by ones again. You can always change your scale if you need it to be like a specific, like maybe you go by 2s if you want to fit something better on your graph. But make sure that you adjust that scale at the beginning, because both of your graphs need that same scale, right? Okay, and then we'll graph our parent function here, or our transformed function rather. Okay, one other important thing to remember when we're graphing this specific function is that this point right here is the starting point of my graph, right? That graph doesn't go any further after that point. So we need to be mindful about where our starting point of our new graph gets transformed to, because this is my starting point of my new graph, and I don't want to draw arrows going in both directions, right? I'm only going off of one side here. I don't want to be going past the point 3, 0 and extending it in that opposite direction, okay? So pay attention to where that 0, 0 point gets transformed, because that's actually the starting point of your new graph, and it goes off the other end, okay? So you only have arrows on one end, an arrow on one end of this graph. Okay, and then our equation for our new transformed function, I'm removing the f, and around this whole set of brackets, I should have a root. So it will be our new function g at x is equal to negative, and then underneath the whole root there, we have 2x minus 3. That's our new equation. Good? Any questions for this one? Okay, you guys are going to be pros at transformations once we get to the end of this unit, because we're kind of doing the same thing over and over again with different functions. Can I scroll? Okay. All right, we're going to do our pre-prediction here. What transformations do we have? Let's start with that. A, D, and C. Very nice. Okay, so, oh, by the way, in this final thing here, did this look similar to our prediction? Yeah, it did actually. So that tells me, it gives me some peace of mind that I've probably done that correctly, right? So that's kind of why we do it, right? We get that peace of mind that I did it right. Okay, so here's the parent function. What is this first transformation telling me to do here? What is the a value? Okay, flip it. That's the first part of a. And then this is a vertical stretch by 2. So imagine we take this and we do this to it. So what this is going to look like is kind of what a horizontal compression would look like. It's not exactly the same, but it's probably going to look something like that if I take it and I pull it. Think of it like an elastic that I take and I pull. Okay, so this is 1. And this is 2. And then 3, what does 3 do? D value, Joey? Yep. Okay, so take your blue one, work off of that one, and then we're going to go 1, 2, 3 to the left. Should still have a similar shape to that blue one. So that's our third one. And then fourth one, C value. What does this do? Down 1. Okay, so then we'll shift this guy down 1. So it should look something, maybe not quite like that. It should look something like this. So that would be our final graph. Good, okay, so that's what we're kind of expecting our final graph to look like. It should be kind of over in that bottom left quadrant over there. And it should be, maybe it looks like it's been like stretched a bit. Okay. So let's do our transformations. We should be pretty good at this point, I think. We're getting there. Here's my parent function. This is what we're starting with. And then we're going to do our new points. I should have x minus 3, very good, switch the sign of the D. And what should that other side look like? Maria? Very good, negative 2y minus 1. A and C go with the y, k and D with the x. Here we don't have a k. Or the k is 1, we should say. Okay, so subtract 3 from each of your x's. We get negative 3, negative 2, 1, and 6. And then we're going to take each of our y's on the right-hand side there, multiply them by negative 2, and subtract 1. So here we get negative 1, negative 3, negative 5, and negative 7. And then we're going to graph. Okay, so I think we can safely go by ones here to fit everything. So you can just draw your little scale. Draw your parent function. Label your parent function. And then we're going to plot our new points. So negative 3, negative 1. Remember, I'm keeping an eye on this point right here getting transformed to this point right here because that is the start of my graph. So I don't want to have arrows on both sides. I want to have arrows on the ending side. And then -2, -3, 1, -5, and 6, -7. Okay, and remembering that this point right here at -3, -1, that's like our starting point. So we don't want to have arrows going the other way. And then final equation. We've got negative, remove the f, and root over the whole bracket. And the -1, the -1, should be on the outside of that root. Okay, that looks actually pretty similar to the one that we drew above. Looks pretty good. Are we good for this one? Okay, why don't you guys try the next one? I'll put my solutions up while you guys are trying it, so see what you can do with that. Try to do your pre-prediction. So this is the one that we're going to work on. This one has A, K, D, and C, so see what you can do with that. Okay, see, first make a prediction and then do your points. Okay, so I made an initial prediction. Okay, I showed my flip, or not my flip first, I showed my stretch first, and then I showed my horizontal flip in the blue, and then I showed a horizontal stretch by 2, which kind of like imagine that you're taking it and you're pulling it horizontally. It's going to kind of go down a little bit like this. And then I did my shifts all in one. So I went left 7 and up 1. And you can kind of see that our final graph looks a little bit different here. And that's just because I've compressed the scale of this a little bit. So you'll notice on my y-axis, I did every 2 ticks was 5. So I'm kind of going by 2.5s on my x-axis, just so that I could fit this -25, 10 point. If you really can't fit that point, if you can at least fit these 3 points here, the -7, -9, -15 point, that should probably be good enough. But I think we at least want 3 points. Now, you'll notice here as well that my parent function looks a little bit different because of the scale that I've adjusted on the x-axis here. So I've now plotted 0, 0, and then 1, 1. This is like approximately where 1 is, and approximately where 4 is, and then approximately where 9, 3 is. And then this is what your points should have looked like. So maintain the negative there. We just want to do reciprocal of k. So 1 over 2 becomes 2 over 1, and the negative stays. Switch the sign of the d value, and then we have 3y plus 1. So these are the points that you should have got. And I'm also, again, being mindful of how this point right here, the starting point, gets transformed into this starting point. So this right here is my starting point of my new graph, and then the arrow goes off the other side. Questions? We're all good? Okay. Is everybody caught up with where we're at now? Can I slide to our last thing? Emmanuel, are you good or do you need a second? You sure? Okay. We're good? Okay. So last one, you guys had to do something like this in your homework last night. So it actually asks us to create an equation given the information of the transformations in words. So we're going to use the parent function, root x, and then we're going to show what that equation would look like once we do our vertical stretch. We also are going to do a vertical reflection, horizontal compression by half, and then shift left 5 and up 10. Okay, so when we have the root part in this is kind of what we're trying to fill in. So the new function g at x, we want it to kind of look like this. This is how we're going to see it. The k and the d will be shown underneath the root, and the a and the c should kind of be like on the outside. So that's what we want to fill in here. Okay, so vertical stretch and also vertical reflection. Where does that go? What part of the puzzle is this? That's the a value. Okay, so our a value is our vertical stretch and our vertical reflection. So what should a be then? Kaylin? -3. Okay, now we're going to do the horizontal compression. Whoops. Horizontal compression by a factor of 1 over 2. So remember, guys, when we write that transformation, we've already used the reciprocal of k. So what k value do I want to plug in here? 2. Good. Okay, so we have to reciprocal this guy. And then I've got my x. Okay, good. So our shift left 2 units is actually going to look like a plus 5 in here. Very good. And then our last one, shift up 10 units. I think that one's pretty easy. We just do a plus 10 over here. And that's our final equation. That's it. Any questions for that one?